Good evening and welcome to the Johns Hopkins University Writing Webinar, Clear and Concise Technical Writing, led by Charlotte O'Donnell. JHU offers free writing webinars to engineering for professionals, students, once a semester. I would like to introduce you to our presenter, Charlotte O'Donnell. Charlotte teaches technical and professional writing at Johns Hopkins University. She has worked as a journalist and as a technical writer and editor, publishing across a wide range of topics and disciplines, from medical journal articles to education policy handbooks. Johns Hopkins Engineering is pleased to present this writing webinar that will cover techniques for writing more clearly and concisely about technical content.
Great. Thank you, Sandra, for that introduction. I'm going to share my screen, just clicking some buttons here. Okay, so hello and welcome. My name is Charlotte and I'm going to be leading you through this webinar this evening. I thought as a way of getting started, I would begin by polling the group with this question. I'd like to ask you guys how many hours per week you spend reading at work. And you've got a couple options here. You can read A is less than 5 hours a week, B is 5 to 10, C is 10 to 20, and D is going to be more than 20 hours a week. I've got to click on a button and launch this. Let's see, hold on. Launch this poll. So go ahead and vote and tell me, how many hours a week do you spend reading at work? Oh, good. I'm seeing all the data coming in right now. We're getting close to 50. We're at about 40. 42 of you have responded. Good. Okay. And so I'll end the poll now and I'll share the results with you. And so it looks like we've got a range of people all over the map that are spending a various amount of time reading at work. And I think this is useful to know, right? Because in many ways we're writing to communicate to our readers. I'm going to stop sharing the poll now, and I'm going to ask you another question that builds on the first question. The second question is, how much of what you read is well written? This is a very different, very different kind of question. And A is 100% is super well written. B is about 70%. C is 50%. D is 30%. And we're about half the group has responded to the poll. I'm going to give another 10 seconds or so for people to answer. Good, okay. So I'm going to share the poll with you. And you can see the majority of you guys say that, like, you are obviously encountering a lot of written material that's not super well written for a huge portion of your working day. So I'll stop sharing this poll. So I'm hoping if you can put these two questions together in your mind, what you'll realize is that bad writing, it wastes a lot of time, right? And in addition, bad writing causes a lot of other problems at work. In case some of you guys are thinking more deeply about it or interested in thinking more deeply about it, why does the writing at work matter? Well, it does more than just waste a lot of time of the people around you that are reading your work. It also does things, according to a Harvard study, that affect the business on a larger level. So if you think about it more holistically, bad writing, it frequently does things like dilute leadership. If your boss is writing a document that's unclear and the document is meant to communicate to a wide base of employees, then a lot of times the employees will end up being confused. And if the employees are confused enough, they're going to lose faith in the boss and that the boss is making the right decisions. In addition to that, the Harvard study on this particular principle talks about how bad writing obviously destroys customers' faith in your company or brand, or your engineering firm, as the case may be. If customers don't understand what your product is about, what your service is about, what your project is about that you're partnering with them on, then they're going to have a hard time figuring out why you're doing what you're doing. And when they can't trust that you do what they think you say you're going to do, then they'll lose faith. They won't want to work with you anymore. They won't want to buy your product. And lastly, and I think of this last option as sort of the inverse of point number one. Bad writing at work in many ways makes management way less effective. And you can think of this sort of from the opposite perspective of the leader at the top who's writing to the employees underneath. Think about all the employees underneath that are sort of writing in kind of like a middling way, like sort of clear, but sort of not clear. Yes, it's wasting a lot of the boss's time when they're sort of trying to sort through what these various employees' documents mean. But in addition to that, when the boss is sort of trying to gather what the employees underneath him are trying to say, a lot of times he's probably going to misunderstand what they're trying to communicate to him. And those misunderstandings over time, they can lead to some pretty poor decision making. I see there's probably a bunch of stuff going on in the chat field, but in order to sort of get through this presentation, I'm going to probably ignore the chat field until about the end. If you guys are having technical issues, though, definitely tap Haley. Haley will help you, and I will hopefully be able to check out your questions at the end once I've gotten through a certain amount of this content. So bad writing has all of these impacts on any kind of business and any kind of working team. There's a certain kind of engineer that I work with, although thankfully they're getting more and more rare out there in the world. But those engineers, some of them believe that, you know, your success at work, it's based mainly on the quality of your ideas. Maybe they say they're not great at writing, but they'll make up for it with math or perhaps with clearer diagrams. But the truth of the matter is that these days, it's more and more and more important for STEM professionals from the whole range of fields out there that they be able to use written language really, really well in order to communicate their ideas. And in fact, usually what makes or breaks a project is the caliber of their communication skills, frequently in writing, which is challenging, right? So what I'm going to do over the course of this presentation is I'm going to open with a little bit of a story about a communication problem that happened in a company at GM, as you may see here from this slide. And this particular technical communication failure, it caused all of the problems from the Harvard study and much, much more, to be quite frank. I'm going to walk you through what happened and why it happened. And as I walk you through why it happened, I'm also hopefully going to show you guys how to do things better. And hopefully you can learn from GM's mistakes and take these lessons with you into your own working lives after you leave the webinar here tonight. So, okay, to get started, I'm just gonna silence this. The story really begins at GM in the late 90s, early 2000s. And at that period of time, GM was in a lot of trouble. Right in that time period, GM posted a $10.6 billion loss, and they had to cut like literally 30% of their workforce. It was a really tragic time for them. And this was happening because, you know, in the 60s and 70s and 80s, GM was known for its manufacturing of trucks and SUVs, and those vehicles were really popular. But as we enter into the 90s, fuel efficiency becomes more important to consumers. And what GM doesn't really have are many popular small cars. And they come to sort of realize that they need a good small car in order to compete in the automotive industry. What they've been known for in the past, they have like one small car or a couple of small cars, I guess. Like one is the Chevy Cavalier, and it's kind of known for being cheap and cheerful, but it's not really slick. It's not really popular. No one wants cheap and cheerful. What they want is something that's sort of like a European style touring car, something that's like a little sexy, that has a little bit more like power on the road, that handles more in a more agile way. And so so GM goes out on a limb and they say, okay, we need to develop a car like this. And what they decide to do is they come up with a plan for a car called the Chevy Cobalt. Some of you guys might be familiar with the Chevy Cobalt. The idea of the Chevy Cobalt in many ways was spot on. It was a brilliant idea. It was an idea that was going to save GM. But in practice, even from the get-go, in the prototyping stages, the Chevy Cobalt suffered from a lot of problems, and in particular, a lot of problems around the ignition system in the vehicle. And so I'm going to take you a little bit into the long saga of the ignition switch on the Chevy Cobalt. Bear with me. So the Chevy Cobalt's ignition switch, it actually began to be developed in 1997. This was sort of well before the Chevy Cobalt was launched. And it was developed as a common part to be shared with the Saturn Ion. Right at that time, Chevy had recently acquired Saturn. And so the idea was to use the ignition switch from the Saturn Ion in the Chevy Cobalt as well, because they were relatively similarly sized cars. And the switch itself was designed to be more cheaply produced and also more reliable. There'd been some issues with the switch's ability to start the car in the past. Also, apparently, it had a habit of setting on fire every now and again. So they were like, well, we don't really want that to happen anymore. So we're going to design a more sophisticated switch. The switch was more sophisticated, but not more successful. The switch, in order to be produced cheaply and to be more effective, they designed it in a way that was much more electrically complicated. It had multiple points of electrical contact within the switch. And though that was supposed to make it communicate more effectively with the communication network across the car, it didn't really communicate any more effectively. In fact, there were all kinds of electrical problems with the switch from the start. And if anything, all of those electrical points of contact within the switch, what it really achieved was creating less space for some of the mechanical components, which made it a real challenge for the design engineers that were tasked with figuring out what to do with this part. So even when the switch was sort of going through prototyping, the electrical concept of the switch, they needed to fuss with it a lot. Everyone on the engineering team had to do a lot of adjustments. It wasn't communicating with the system in the way that they thought it would. The electrical current wasn't traveling through the switch in the way that they thought it would. And so that had to be redesigned a number of times. And then as they sort of got to the later stages of the prototyping of this particular part, what they found in addition was that there's this part inside the switch. It's basically like a metal groove that is it's responsible for holding the switch in a particular position from start to accessory to off. Anyway, these little grooves in the switch called détentes, they were too shallow. And so because they were too shallow, there's a component that basically presses into the groove. And the shallowness of the groove meant that the switch didn't hold its place. And it sometimes was caught sort of in this weird in-between position. Like engineers found that the switch sometimes sat between start and accessory or between off and accessory, which is obviously not a thing that you want to do. So anyway, so they eventually have to totally redesign the switch with different tools. And there's some other things that are coming up too. They notice at the same time they're redesigning the grooves in the switch, the détente, that even after they redesign the grooves, the torque requirement on the switch isn't quite right. It's supposed to be, it's supposed to take a certain amount of force to turn the switch from off to accessory to like crank and start. And it's almost like if you very, very gently brush your hand against the key, it moves too easily between these positions, which is sort of troubling. But this particular problem, it gets a little bit lost in the fray. They have a couple of conversations with it between the engineering teams and the manufacturer that they're outsourcing this part to. And then someone drops the ball, essentially, and they kind of forget about it. And the switch gets installed into a vehicle and it gets released with the Ion as its standard part when the Ion is launched in 2002. And even after the Ion is launched and they think they've solved all the problems, there are even more problems with the switch, problems they hadn't anticipated. Suddenly it's no longer that the switch is sort of between stages. Now it's that the switch actually does not start the vehicle like they want it to, in particular in cold weather. So then the next 2 years, they basically spend trying to figure out how to fix this cold weather starting problem. Actually, at first, they really are having a lot of debates amongst themselves about why the car isn't starting to begin with. A lot of the teams don't agree on like what the cause is of the cars not starting. And it's only after one of the engineers actually goes to the trouble to build a refrigerated cargo carrier and drive an Ion into the cargo carrier and test the switch in cold weather that they come to the conclusion that it's the cold weather that's messing up the ability of the switch to turn on the car. So they do eventually fix it in 2004. They redesign the switch yet one more time. They're pretty embarrassed about it. In particular, the lead design engineer takes this like 5th or 7th redesign of the switch as a mark of personal failure. He feels really ashamed of this. But you know, they've got to go forward. They don't have any other plans for what to do with the ignition switch for the Cobalt. And so the Cobalt launches in 2004. With this ignition switch. I should say that at some point between 2001 and 2004, there was another problem in the background just to add to the chaos of this story. And that problem was that some engineers, when they were testing the vehicle, and some consumers, after they shortly after they purchased the vehicle, after it was released to the public, they were starting to notice that the car was turning off while they were driving. And that obviously is really troubling, right? So the descriptions of these scenarios sort of go like, well, the driver is driving on a main street in town, or in some cases on the highway. And what tends to happen is the driver accidentally bumps the key fob that's sitting in the ignition. And this little bit of jiggling of the key in the ignition is enough to actually turn the switch from the run position back to either accessory or off, at which point the car loses all power, and the driver, if they're the panicked type, maybe doesn't handle the vehicle so well. So shortly after the Cobalt launches, they start getting many, many more of these reports coming in. Before, these reports had come in, but they'd sort of been ignored because they were really trying to focus on the no crank, no start in cold weather. But now they're starting to pile up, and between 2004 and 2009, they get a number of reports, and some of the engineers on the team start to get a hold of these reports, and they start to take them more seriously. There is, just to carry on with the general theme, a lot of confusion amongst the engineering teams about what is causing this particular problem this time. And the engineering teams start to bounce around a bunch of crazy theories about what is causing these moving stalls. A lot of the engineering teams, they have a particular theory that this is, they don't understand why it's coming up so frequently in these reports or why people are making such a big deal out of it, but they really think that these incidents are rare and they only happen in a very limited circumstance. Like say with several sort of key events happening at the same time, like the driver turns on the blinker and is accelerating between 40 and 50 miles an hour and has like turned the steering wheel to the left, or like the car is strangely in neutral and the radio is on, or so anyway, they have theories like this, that it's really like a confluence of several very small things that a normal driver wouldn't do at the same time. And so when these incidents come to an internal review committee that is responsible for dealing with the problems and remedying them if they pose a risk to the general public, what this review committee tends to do, it looks at the problem, it's sort of listening to the various lower level engineering teams sort of bickering back and forth with one another. They don't fully understand what the lower level engineering teams are saying, or sometimes it's like the lower level engineering teams, they're not really like interpreting the facts, they're just sort of like sending very neutral, very objective reports up to the top. And the people at the top on this review committee, they're under an enormous amount of pressure to push this car through production and to keep it viable, right? Because the success of GM really depends on the success of this vehicle. And so each of these review panels, there are 4 of them between 2004 and 2009, they come back and they say, well, we really don't think that this is an issue of customer safety. We think this is an issue of customer convenience. We think it's rare. And beyond that, it's not a good business case. So we don't think it's wise for us to do anything. We're basically going to ignore them. So that happens. And all this sort of squabbling is going on and no one's really doing anything. And then secretly, without telling anyone, the lead design engineer on the switch in 2006 realizes that he made a mistake. He realizes in the course of a couple of newer conversations with the company that's producing the switch for him that he had dropped the ball early on in the process, probably in the early 2000s, and had failed to give direction to the manufacturer to adjust the torque of the switch in its earliest stages of development. And so now he's in this position where he's covering his tracks because these reports are coming in and people are getting into accidents. And beyond that, they're getting into accidents and the airbags aren't deploying, and there's even more confusion about the airbags not deploying. But what this means is that people's lives are being jeopardized, and this lead engineer realizes that something has to be done, but he doesn't really want to cop to it. P.S. I should say he's never admitted this publicly. This is just what most analysts say when they examine this case. And anyway, so he secretly, in the process of the latest redesign that's supposed to fix the 10% of the no crank, no start problems that were sort of left over, he redesigns the switch secretly and doesn't update the part number. So nobody knows that the switch is just a totally new part. And after 2006, it is a totally new switch that's 100% fixed. But because GM doesn't really know what's going on and that there is an earlier problem with the switch because the lead engineer didn't say anything, they continue to sort of go about their business, treating this problem like it's a non-problem, all the way up until 2011. When a lawyer files a lawsuit on behalf of a family who lost their daughter in a car crash. And this lawyer actually goes to the trouble to take the ignition switch out of the vehicle. And he actually sends it to an independent analyst who analyzes the switch and the torque in the switch, and it comes back and the analyst is like, whoa, this switch is like, it's too soft. It moves way too quickly between these particular positions. And that's clearly the reason why your daughter's vehicle shut off on the highway and she careened over the side rail and the car tumbled and she died. The lawsuit is filed and the lawsuit finally gets GM's attention. GM starts to do some investigating and executives at the top are like, ooh, something seems kind of fishy here. So GM hires an external investigator to investigate its own people. That's what it takes to sort of get to the bottom of this. And it's only after the investigator comes back, after I think 6 or 8 months investigating, with a verdict that says GM has in fact done some wrong, that GM recalls 2.7 million vehicles. Just to give you a sense of some of the specifics of the components that I'm talking about here, this is a diagram of the ignition switch, and you can kind of see where the key goes in the ignition slot and the key slot. This, I mean, obviously you guys are familiar where the key is in your car. It's mounted to the steering column of your car. And when you turn the key, it turns a shaft sort of deeper in the steering column, which eventually turns a component towards the back of the switch. And the shifting of components at the back of the switch cause a piece of the switch called the détente plunger to click into various slots in the switch. These are the grooves in the switch I was talking about, and they're called the détentes. So the détente plunger, it's basically like a little metal cap that's mounted on a spring, and it presses into the groove in the metal plate. And when the key has enough force exerted on it, it will slide out of one groove and into the next. But it presses hard enough, right, that it stays in the slot unless you exert a certain amount of force on the key. And so you can sort of see how it works down there below. I should say that possibly one of the most tragic things about this case is that the fix of the ignition switch, really all they needed to do to fix it was to replace the detente plunger from the original part, designed in like the early 2000s, with a part that was much, or not even much, just like a little bit longer. And the detente plunger that was just a little bit longer exerted just a little bit more force into those slots, and it held the key in place so that it no longer moved when you bumped the key with your knee. I should note too, the original part of, I think, one of the things that kept them from doing this immediately was that it was just created with an off-the-shelf kind of spring, something they could get really easily and cheaply. The replacement part did have to involve a custom spring that the engineering firm designed themselves. But even with this, the difference in cost of the vehicle with the old part and the vehicle with the new part was really just a matter of cents. So just like less than $1. And is that less than $1 worth all of the trouble this switch caused? Probably not. I thought it might be fun for you guys to guess at this, now that I've described this full incident. How much do you think this incident cost GM? I'm gonna launch this poll now. Was it just 124 people died and 275 people were injured? Was it 2.7 million vehicles recalled? Was it 2.6 billion in penalties from the federal government and settlement costs? Or was it all of the above? I'm hoping that you see it was all of the above. It was really just an outrageous amount of money that went into both fixing this problem in the end and fixing the company as a whole, because clearly it showed some major flaws, I think, in management and in the communication style. And so congratulations, you all did really well on this multiple choice question. What I have to say sort of beyond this is that this problem, clearly it had many causes, right? And sure, there are failures in leadership and there are failures in management, and there might have been failures in moral courage in some circumstances. But one of the primary causes of this massive problem at GM was really a failure of technical communication. And I think probably like the primary like theme to this like failure of communication at GM had to do with the culture of communication that many executives and mid-level engineering managers were sort of fully enmeshed in at the time. And this is, it's a cultural phenomenon that I see really across a lot of engineering disciplines. And it's one that I try to sort of like illuminate to hopefully encourage you guys to do a little bit better. And this is maybe a simplified way of explaining it, but what I say frequently when I'm teaching communication is that there is a kind of like cult of very serious STEM writing that exists out there. And when you write in this style of very serious STEM writing, what you're doing as a writer is you're sort of prioritizing in your writing process this idea that it's not so much how clear you're being, it's that you're being taken seriously. And so what you do instead of prioritizing clarity is, like, in many ways, especially if you feel not confident about your writing, you might really just choose to write like how you think other people write or how they sound. Sometimes you write in a way that's a little bit defensive. In the case of the lead design engineer for the Switch, who failed to reveal anything about the changes in the part in 2006, he wrote to intentionally obscure what was going on. But none of these are good ways to approach the writing process. I hopefully all of you guys agree with me on this, really feel that it is incredibly important when you're writing about technical material, which is already so hard to understand on its own. You have to approach it prioritizing clarity. There is no reason that technical writing can't be made easy for an audience to understand. It's perhaps a more complicated process figuring out how to communicate clearly, but there's nothing inherently special about sentences that describe technical content versus sentences that describe non-technical content. And so I'm going to try to persuade you of this case over the next couple of slides. Don't write like Ray DiGiorgio, who eventually got fired and could be argued was responsible for the death of like 150 people. You know this.